is it one of those devices that it needs to be in the ambulance, and it's going to be transported with the patient into the hospital until they can set them up on the bigger system. So we're seeing more and more of that. We're trying not to move our patients around. We're trying to, again, move our equipment with the patient versus trying to get the patient to move. There's a lot of reasons to do that. But what that does is, again, it talks about our products. Like before, you know, a typical PC, puts it on a desk, it's fine, it's not going to get damaged. But if I have to move this thing, I need to come up with maybe different mounting brackets. Same device, I'm not going to change it, but if I'm going to have it as a mobile unit, I need to have it as mounting brackets. But if I'm going to put that device in for a cart in the hospital, maybe not an issue. I want to put that on a Humvee in a war zone, or if I want to put that on the back of an ambulance and have that be able to fall off the back of a fire truck, or things like that. We're going to use that same product, and we talk about from a manufacturing standpoint, we're going to build that same thing. But I may need to build a rigger shell or something, you know, more durable on the outside. And so, again, as our customers being our patient in this case, don't really come to us, instead we're going out to them. We're now looking again at that same kind of concept of how do we sort of care for them where they're at, get that information back into a more traditional setting, and then interact with them. So, and in some cases we may have to leave that device behind with the patient, and we want it to be able to survive for a period of time in a variety of different circumstances. Again, hospitals are very messy, so even if, you know, that's going to stay with the patient, and maybe the patient is in the hospital, but they're going to sit in a wheelchair waiting for an MRI or an X-ray, they have lots of like ooey gooey fluid stuff that comes out of places that just are not natural to me. And so, you know, we're building a lot of new devices that are waterproof, because, you know, taking this kind of feedback of somebody vomiting and all this, I don't even go in the rest of where things come from, you know, more, you know, water pack, you know, and so, and sometimes that device then goes home. You know, they pull it out and promise to get rid of the yucky part of the package, and the main device inside is good, and they can send it home. Because what the example I can give you is sleep apnea is a big problem these days. You probably hear a lot about it in the news. So people have CPAP machines. So for we have a lot of people who are struggling with weight in this country, and sleep apnea is one of the side effects of having, not the only reason, but one of the effects of having being overweight. And so that mask that you use at the hospital, patients, because it is their germs on it, you don't want to have to go buy brand new masks all the time. They're really expensive, and you don't want to have to keep switching them out, because every time you take that mask off of you and I have to put it down here to give you a breathing treatment or treat you in some ways, I've now contaminated it because it's touched a surface. So I have to throw it away and I have to buy a new one as a hospital. Instead, if I could take that same one and I can somehow, it's a lovely headgear for anyone who has sleep apnea, God bless you. If you're married, because your spouse is safe, because it's like this big like headgear thing you have to wear, so it's quite attractive. But this headgear, instead of having to take it off and put it down and then have germs and things that can be really put on your face, especially like a face injury, or if you have any type of asthma, you're breathing in those germs and you tend to have other issues and complications that come from that. But basically, if you can take these lovely face masks and they're with this lovely headgear and you can flip them up, you can not touch it and you cannot contaminate it. And it's your germs, it's your disgusting mess, so if you don't like it, then you know it's your own self. But the nice part is we can talk about patient safety, and we can talk about, you know, not cross-contaminating and not sharing, you know, germs and things of that nature. But again, it goes home. And so those customers want them at home because it's a product they got used to at the hospital, it worked really well, and I have to now wear the CPAP machine for the rest of my life when I sleep at night. And so those ordering those like sleep apnea masks, you know, those consumers again would be another example of where the environment is changing, and we need to build products that can transition from one location to the next. So I've sort of talked a lot, and I can talk a lot more specifics if you guys want, but I thought I'd have to change because it's where I live these days. Before I So, yeah.
Yeah, well, I actually got a question. Since you're involved in the medical field, what type of quality control do you actually use? Do you use any standardized system into your process? Do you have any process? Can you talk a little bit more about this process?
Yeah, so I mean, there's probably not a Six Sigma class you didn't take that we don't use. So your traditional, you're really, in medical devices, it's the same traditional process you use. So we really start all the way back at your partnerships with your vendors. So we try not to inspect in quality these days. That's sort of an older term, sort of an 80s term if you've been sort of such an old man. We used to try and inspect in quality, which meant that you sort of inspected every single element of everything you did from the moment you walked in the door, and you tried to bring quality into the product as opposed to designing quality into the product. So one of the things that we've done and made a lot of changes across the industry, and you guys, learned a lot about this in school, is we talk about from the very beginning when we talk about R&D, we talk about that relationship, and I really focus a lot on the customer because you have two instances that you interact with that customer. You interact in the beginning when you sell that customer a product, and you interact with that customer again when you service that product. And those are your two touch points with your customer that you're going to have. But between those two touch points is a lot of stuff in between. And what we need to understand is how the customer's buying your product, what are their demographics, where are they living, what kind of money do they have to spend on this, sort of all those things. And then how do we service this product later on? And why that's important in the very beginning before you built your very first product is you need to understand the end game before you can start the game. And so what we do is we talk about design in the very beginning. When we start coming up with a concept, we look at how do we manufacture this product, how manufacturable is this product, what kind of partners do we need to get to manufacture this product. So what kind of relationships, and then we need to look at, we start in the very, very step one, which is when we select a vendor, doing our vendor selection quality analysis, and say, what kind of quality standards does this vendor have? What kind of quality control processes do they have? Because what I don't want to do is try and figure out quality later on when I'm manufacturing it. I want to make sure that the quality I get of the raw material coming into my facility meets the standards I'm looking for. So, we'll look at, SQL levels, we'll look at, parts per million, depending on what the product is what's appropriate for that. But we'll start literally before we build our products. And that's really where, if you're thinking quality in manufacturing, you've missed it because you're going to get a bunch of crap and it's too late. Then you're fighting with your vendor over it's not my design, it's your design, you sent it to me, I built it to your spec, blah, 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 and you end up fighting over it. But we start in the very beginning, really with our partnerships with our vendor, qualifying a vendor, building a relationship with that vendor, doing the first articles when they first come in, do they meet this, our quality standard that they expect? And then at that point, we talk about sampling plans. We do sampling plans a little bit different, not that we don't do them traditionally, but what we typically have is, we use a military spec, but we also do what we call random sampling plans, dynamic, sampling plans are different terms. We automate them, and so basically what we do is we also don't treat our vendors, I don't want to say we don't treat them equal, but we treat each material within that vendor as its own component. So just because you may be a large manufacturer, if you're really good at building boards, I don't want to inspect and treat you, and have to scrutinize your boards the same way where if you're maybe building me a plastic mold and you're really not good at extruding plastic or powder coating, maybe you have some quality issues there. I don't want to treat them both exactly the same. So we actually, yes, we try and build a relationship and have, the fewest number of suppliers so we can control the quality, but we also look at treating the supplier quality along with the components. And the quality of the components we get there. We create separate sampling plans for each one of them. So as a vendor, you know, maybe when they're coming on as a new supplier, we may inspect 100%. But then after, for example, 20 shipments, and they've met our quality standard, then we're going to move them to a, you know, maybe a sampling plan. Okay, we're going to inspect one every 25, and they meet that quality standard. Now we're going to inspect one every 100 shipments. And then we build this process back to the point where we stop inspecting them until we have a failure in the line that has occurred. And then at that point, then the vendor goes back on inspection and, you know, goes back on to make sure that their quality is in control. But we start that, like I said, in that very beginning process. Now, we also don't wait when we're talking about products when they're going through the manufacturing process. We also look at the testing throughout the process. You know, most work cells are lean these days, you know, using the whole Kaizen approach. And so, you know, they're set up as work cells. You know, individuals are really encouraged to contribute and look at quality. We have a ton of, well, we have in manufacturing testing, so we don't wait again until the very end and do final test inspection to make sure everything meets. There's a series of tests that are done along the way to make sure that they've met the requirements. You know, typically manufacturing will have things like daily stand-up meetings, and so we'll look at each one of those work cells and look at their daily yield or their daily throughput, and we'll look at see what's happening with it throughout the day, instead of, again, waiting till the end of the week and waiting for some engineer who's hiding away in his cubicle and isn't talking to anybody. You know, he'll have to come out every day on the manufacturing floor, and we'll talk about today's yield. Okay, what's my yield at HiPod? You know, HiPod's an electrical test that we actually provide. You plug in the device and you stick it in a saline solution, you push the button, you try and blow it up. You're looking for basically holes, leakage, where you can electrocute somebody. That's really what the test is, doesn't really matter, but. But we'll look at that. I mean, and we'll say, what's the throughput? You know, what's the throughput today? How many units did you pass through it? How many devices failed today? Because what we're looking for, an example of that is, we're looking for two things. We're looking, in the case of the HiPod example, we'd be looking at epoxy quality. Do we have small, tiny little pinholes and air bubbles that manifest after baking in the oven in your epoxy, which later then cause air and liquid and water to get inside the device and cause corrosion, and corruption is what you see on the back end when you have poor epoxy that goes out and it doesn't close the seams. What you find out is hospitals disinfect these darn things, they submerge them in water and they clean them. And what you do is, if they have these little tiny, tiny, tiny pinholes that you cannot see to the naked eye, what you find is you get a device back in less than 12 months and you open it up and it is completely corroded inside. And so each one of those tests that we design along the way are really intended to look at material quality, quality of the process itself. Do I have that same process? Maybe I don't have problems with my epoxy, but maybe I have a new employee on the line. Maybe that employee has not learned the proper technique for setting up the epoxy, as an example. And so they're really, it should look like butter. It should look smooth and clean, you know, but if I don't have the right technique and I really haven't got it, I don't have good dexterity in my hands, I may look like chunky peanut butter instead of, you know, smooth, creamy butter. And so we want to focus on that throughout the process, and we don't typically wait now until the very end or until days later to look at that data. Typically what you're going to see in a manufacturing floor is you're going to see that meeting daily. You're going to see that meeting all the time. And then that data, if it is, you know, going back to the example with the epoxy, if it turns out it's the manufacturer, that manufacturer of the epoxy is going to get a phone call, usually the next day, from their quality engineer. Hey guys, we got a batch 1, 2, 3. Yesterday we ran it through, it didn't work. They make these things called pucks, but don't worry about that. They make these little things called pucks, we send them back, we slice them up, and we can show the quality of it to the supplier. So that way, again, we're not proliferating my entire manufacturing floor full of garbage. I'm able to usually go back to my inventory cage at that point and say, this batch of epoxy is bad, let me pull it all. And because I've created this great partnership with this vendor, I can usually just send it right back to them and they'll send me a replacement, because they probably have you know, depending upon your process with your purchasing, but they probably have anywhere